Hey, hello there. So today I'm talking about this question, 138, copy list with random pointer. We have a linked list. The thing that's special about this linked list is that the nodes inside this linked list contains not only a next pointer, which points to obviously the next node in the sequence, but also a random pointer that could point to potentially any node inside this list, or it could be a null pointer. Now, our goal for this question is to create a deep copy of this list and return the head node to the of the copied linked list. So as a simple example, we could have a linked list with maybe like 3 nodes, and the links I'm currently drawing are the next pointers, and maybe just one of the node here, node 2, it might contain a random pointer that's pointing to a node 1 inside this linked list. Just gonna note this as a random. For the other 2 nodes, they might have some random pointer. Yeah, I guess for the sake of this example, we can just treat them as just imagine that their random pointer is null pointer. So I'm not really drawing that out. So now our goal is to make a copy of this linked list with random pointer. So obviously, if we traverse through this linked list using only the next pointer, we can very easily make a copy of this. Then maybe in the second round, we can try to establish this random pointers. So to do that, we can iterate over this 2 linked lists simultaneously at the same speed. So when we look at the first node in the original linked list, we also have another pointer that's pointing to the same corresponding node inside this new linked list. Then if we have a random pointer that we find the node in the original linked list has a random pointer, that means for the new linked list we want to have establish a random pointer pointing to the corresponding node for the new linked list. So for that reason, we would want to have a mapping from the old node to the corresponding new node. So I'm just gonna note down here. It's gonna be 2 paths. The first pass is to create a copy with correct next links. Also create a mapping from old to new. It's too long, put it into 2 line. So after that, the new linked list will look like something like this. Second pass is to traverse these 2 lists at the same pace. When we see a random pointer in the old, we set new node .random to be this mapping old .random. Yeah, so just look at where this random pointer points to in the old linked list, and then look up the corresponding node inside the new linked list, and have that points to over there. So yeah, after this 2 pass, we will have a deep copy of this original linked list with a random pointer. So that's the very straightforward way of solving this. It will be linear time and linear space. Linear time being that we do 2 passes, and the linear space is that we maintain a old node to new node kind of a association. So that map will require n space. So that's pretty much the first way of solving this. I'm going to talk about another constant space solution, which is a little bit tricky, but here is the very straightforward one we're going to code up first. So obviously the first thing is to first pass, create a copy with correct next. Second pass is to fix the random pointers. Yeah, so beyond this, we also need a map that keep track of the pointer mapping. It's okay that we put the pointers as the key and values. If we put the object as the key and values to this unordered map, it will be require actually the node to implement some kind of hash function, and it doesn't seem to be the case here, so that's why I'm just putting a pointer. Yeah. Ode to new, let's just call this. And we're gonna have a sentinel node which is just a dummy node that have a next link points to the the head node of the new copy. So that's gonna be some dummy new node with whatever value, I don't care, and just gonna have a copy that's pointing to this dummy in the beginning. And does it mention how many nodes is guaranteed there to be there? We only have an upper bound, there's no lower bound. Yeah, so maybe just catch that here. So yeah, let's do the first pass. So we're gonna make a copy, and yeah. We're gonna take the value from the node in the original linked list, and use that value to create a new node. Have the copy, the traversal kind of a pointer for the copy, the linked list next to points to that, and then just gonna advance this to be this newly created node. Then what we're gonna do is to advance the old pointer as well. But before that, we're gonna insert this relationship into this map here. So it's the ode to new. Then we advance also in the ode linked list. So that's the first pass. Then the second pass is to iterate over them at the same time, and when we see a random pointer in the old linked list, in the nodes that from the old linked list, we will try to fix the random pointer in the new one. So we just move this traversal pointer back to the head, and move the copy back to the beginning as well. Then what we're gonna do is to iterate over them at the same time with the same speed. Obviously, some code we can quickly put up here is to advance them at the same time, at the same pace. If the node in the old linked list have a random pointer, then we're gonna do is to have the copy random pointer points to the we look up that new node associate to the corresponding new node inside this new linked list. So yeah, so that's pretty much it. Return the sentinel nodes next, which is going to be the head node to the newly copied linked list. Not working. Not much in constructor initialization for the node. So okay, so it does take it has to take at least a value. So let's just put a 0 there. Okay, looks good. So yeah, this is the most straightforward way of solving this. We do 2 passes. The first pass is to create a copy with the next link that's correct, and also maintain a map from the old nodes to the new nodes. Then in the second pass, when we see a random pointer in the old linked list, we will try to do the same in the new one. So after that, we should be able to have the complete deep copy of the old linked list with random pointer. So that's the solution number 1 with linear space and linear time. So I'm gonna talk about another approach. Gonna borrow this as well. Another approach that requires only constant space. Obviously, we wouldn't maintain this mapping from the old to new. So that the way we do that is just to put the new node temporarily in between the old and its next. So it will look like something like this. I'm using prime to indicating this is actually a copy node. We can very easily insert this one, when we iterating over the new old original linked list. For every node, we just create copy of that node immediately after that. So we need to basically insert that between the original node and its next. So in the first pass, we can do this. And obviously, we only have this random pointer correctly working for the original node, not to the copied one, because the copied one in the first pass we're not gonna be able to figure out that yet. Because if you have a node that's pointing to some other node after that, when you first create the copy, there's no way you can pointing that to the correspondent copy. So that's first pass. So I'm just going to summarize this. The second pass, we're going to make sure that the newly created node also points to the, we're going to fix the random pointer. So it's similar to that. The first one, we just only able to get the next working. You can see that if we just want the original linked list, what we need to do is to instead of do the usual way to go to the next, we go to the next. If we just hop 2 steps at a time from the head node of the original linked list, we would basically only traverse the original node. If we start with head.next, from this head node of the copied linked list, and we also do 2 hops at a time, we will only be traversing the newly created copy. So for that reason, it's easy to separate those two after we fix the random pointer. For the random pointer, for the particular, let's say that we're looking at node 2, we can follow the random pointer to go to its associated node inside the original linked list. But the .next here, note that the .next there is its associated the node in this for the new linked list. So we're just going to have this nodes .next to 2 prime points to its random pointers next. So so that's going to be the middle iteration. I'm just going to note it down here. yeah, just gonna summarize this very quickly. It's getting quite late. So yeah, first iteration, first pass, insert a copy between ode and ode.next. Second pass, for a node with random pointer, we're gonna set node.next, just gonna call this ode.next, which is gonna be its copy in the new linked list .random equal to o.random.next. So in our case, in our example here, 2, its next is gonna be 2 prime. 2 primes next is going to be 2's random, which is going to be, I'm just going to using brackets here to indicate that the 2's random is 1 and the next is 1 prime. Yeah, maybe just that, 2 and 1 and 1 prime here. So yeah, so that's pretty much just setting 2 primes random link to 1 prime. So after this second pass, we established the correct random pointer in the new linked list. Then it's just split the linked list. The odds one. The odds nodes are the old one. Even number of nodes are the new one. So yeah, so it's going to be 3 pass, and it's going to be constant space because we don't have that mapping, and the mapping, the essential job of the mapping is being captured by the next link. So yeah, in the original. In the first solution, we have to use this map to keep track of node 1 is this 1 prime, node 2 is its mirror is going to be 2 prime, but here the copy node is immediately after the origin node. So we don't, for that reason, we don't need this linear space mapping. But we do have to do this in 1 more pass. So yeah, you see that this is a 3 pass. For that one, it's 2 pass. So even though that the time complexity is going to be dropping the constant multiplier, it's going to be the same order of n, but this one does take a little bit longer. So yeah, with that, I'm just going to code this up. Oh, sorry. That's not supposed to happen, but anyway. So we're gonna have a node to traverse in the old one, and we're gonna have a copy and also a node indicating the head node of the newly copied one. We're gonna use this to start collecting nodes, even and odds later on. So the first pass. While traverse, copy is going to be a new node with the nodes value, old nodes value, and we're gonna set this nodes next to be the original old nodes next, so that we insert it in here to have it points to 2. And after that, we can have the old one points to this. So that's this. So with this, we should be able to advance. We have to hop this to by 2 steps. Or we can just hop it to the copy nodes next. So that's 1 pass to insert a copy of the old nodes. So the second pass to fix the random pointer. So we move this back to the head, and we're just gonna set my next, which is gonna be the new node, and have its random points to if I do have a random, which is not a null pointer. If that's the case, I'm gonna set this thing to yep. It's a little bit too long. Let me actually put a if statement here. Cool. Otherwise, it would just be the default, which is going to be a null pointer. So after that, I can traverse 2 steps at a time. So yeah, because if I traverse 2 steps at a time, I'm only looking at the original nodes inside this sort of fused linked list. So that's the second pass. And the third pass is to it's essentially the other questions on Leetcode. It's the even odd split the list into even odd lists. So the odd list is going to be odd number of nodes. Node 1, node 3, node 5. It's going to be the old linked list. The even number of nodes here, node 2, node 4, node 6 is going to be forming the new linked list, the copied linked list. Yeah, so move this back. So we're gonna pop this two step at a time. Actually just gonna be 1 step at a time. We're gonna fix the link so that we only need to jump once. And yeah, here it's just to remove to make sure the link works okay. And copy is next. Or this is more readable, I think. So yeah, so we are even. We jump 2 hops at a time. The only difference is that the copy is got actually, when we traverse at the same time, it's got actually 1 step ahead in the fuse the linked list. So it's even though we advance them at the same pace, the copy is gonna likely to hit null pointer before this traversal node. So for that reason, we need to do a condition check here to make sure that the copy.next is not null pointer. If that's null pointer, then this will be undefined. You couldn't call .next pointer on a null pointer. So that's why this looks slightly different. Yeah. So after that, we just return the new head, which is going to be the initial nodes for the copied linked list. So this is 3 pass and constant space. Let's see if it works. Okay. Alright, so slightly faster. Not really. Yeah, not really. Alright, so yeah, that's this question. 2 solutions. One straightforward 2 paths with mapping. The other one is the 3 paths with constant space. It's not too difficult to think about this. You have to find some way to replace the job of this mapping. That maps the old node to its correspondent new node, and to do so, the only thing that you can really rely on are the 2 pointers. Obviously, you don't want to mess up the random pointer, so the only way to utilize the next pointer to keep track of, to function both. First, it has to still functioning as the pointers you can rely on to correctly traverse inside through the linked list in the correct order. The second thing, you have to also keep track of the relationship between the old node and the new node. So the way to do so is just to insert the new node in between, so that if you want original traversal order, you just hop 2 steps at that time. If you want to find the mapping, you just look at the immediately next. Alright, hope it makes sense. Yeah, that's it for today.